Determining sample size. So we can determine sample size for the mean and also for the proportion. The required sample size can be found by obtaining a desired margin of error or bounded error B with a specified level of confidence. So this margin error, we call it as also sampling error, which is the amount of imprecision in the estimate of the population parameter. The amount, which is the amount added and subtracted to the point estimate when we construct the confidence interval. Determining sample size for the mean. So this is the formula to construct confidence interval for mean, population mean, which is the mu. So it is the point estimate or sample statistic x bar plus minus critical value and standard error. So this plus minus the right side here is the sampling error or the B. So we have B equals to Z alpha over 2 and sigma over square root of n. So from this formula, we need to solve for n. So to solve for n, you can bring this square root of n in the denominator to the left side. So we have square root of n times b, and then solve for n, we have the right side divided by b and square root everything. At the end, we're going to have z alpha over 2 squared times sigma squared over b squared. So example, you have sigma equals to 45 and you want to know what is the sample size needed in order to estimate the mean if the sampling error is within plus minus 5 with 90% confidence. So we have this formula n equals to z squared sigma squared over b squared. So we are referring to z. Z is going to be uh, alpha 10%, so the upper tail area is going to be 0.05. So we found out that it's going to be 1.645 and then square it, and then 45 is the sigma and over 5 squared. So 5 here is the sampling error. So solve, we got 219.19. So the required sample size, we're always going to round up to the greater value. So it's going to be n equals to 220. Determining sample size for the proportion. So this is the sampling error in the formula for confidence interval for the population proportion. So we have plus minus z alpha over 2 square root of p hat 1 minus p hat over n. So all these will be the sampling error. So from the sampling error, b equals to this, solve for n. So when you solve for n, you'll get z squared p hat 1 minus p hat over b squared. So example, how large a sample would be necessary to estimate the two proportion defective in a large population within plus minus 3%. So this 3 is the B with 95% confidence. So alpha will be 5%. And assume a pilot sample is P hat equals to 0.12. So 95% confidence means alpha equals to 5%. So Z alpha over 2 will be Z 0.025. So from the normal table, we're going to have 1.96. And the sampling error is 0.03 and p hat is 0.12. So putting everything in the formula, you'll get 450.74 and we round this to the greater value whereby we use n equals to 451. So the sample size required is 451.